So AI agents, yeah, I was quite excited to get into this paper. It's the first, I've not really had much exposure to this topic yet, and it's the thing everybody else is talking about. So I'm going to cover off the introduction and then hand over to Adam. Then I'm going to come back a little bit later to cover off some of the bits nearer the end of the paper. Um, I'm guessing most of you, if you haven't read the whole paper, at least you've read the abstracts that gives us an idea of, overall what to expect from this. Well, let me just review that first, just to kind of orient us in what we're going to study here. So they're going to introduce this benchmark called MLE-bench, and it's a benchmark designed to measure how well AI agents perform at machine learning engineering. Well, they're going to need to define what they mean by machine learning engineering, and they do next. So they've worked from Kaggle. So they've taken a bunch of competitions from Kaggle, things that people have already solved, challenges that have been around for maybe a couple of years. Some of them are a bit newer, but they've taken these challenges and they've set up an agent and asked how well can that agent do at solving those challenges independently. That word independently is a little bit loaded, and we'll come back to that when we talk about this question of contamination and plagiarism. But the idea is, can an agent solve these challenges? And if so, how well? And how do we measure that? And that's what the benchmark is about. They mentioned that they are using OpenAI's, well, they're using a bunch of different models and a bunch of different what they call scaffoldings. There'll be a bit more detail on that shortly. But they mentioned that OpenAI's O1 model with this thing called Aid, that's just a agent framework, that gives the best performance overall. And they look at, certain questions around the validity of these results as well. Contamination, for instance, they cover. So let's have a quick look at the introduction and just pull out the pertinent points from this. Um, Kind of, the background to why they're doing this is what they start with, and they mention that language models in general have achieved increasingly impressive results, and performance with coding benchmarks. So we know that modern language models can write code for us, they can complete code for us, they can analyze code and find bugs or refactor it and things like that. And they're good enough that these things tend to be now integrated into our programming tools, right? We have things like GitHub Copilot that we can just use on a day-to-day basis. So we know these work well, but the context in which they are used typically is one where it's kind of a copilot helping you write code. What it's not doing is saying, here is a programming challenge that requires a complex set of requirements, but also in this case, it requires machine learning models to be trained, it requires data to be analyzed, it requires the model to be evaluated. So it requires all of these different things, these different disciplines and skills, in order to complete the task. And the existing models haven't been evaluated in that context. So that's what they say here, right? That while there's been this surge in capabilities, there aren't benchmarks that measure how well a autonomous agent can perform that end-to-end machine learning engineering. And that's why they're introducing their MLE bench. So they describe it as an offline Kaggle competition environment. What they really mean by that is it's an environment that kind of just lives on its own. It, it contains, you can offer descriptions of problems to the agent and have it try to solve them, and you can measure how well it's done at solving them. And these are problems where existing good results are known, right? So human beings have tried to solve these and um, got good results from them. They talk about how many, like the spread of different domains that these competitions cover. So natural language processing, vision, signal processing, and they mention some of the specific ones. Open vaccine is one of them. I hadn't come across this before. It doesn't particularly matter actually what these are. For me, they're just examples of what they're using to evaluate the models. But the final thing they mention is, you know, the prize value. Effectively, supposing that these were unsolved challenges, then this is how much money could be won by someone with a successful agent solving them, right? Just, food for thought there. Not sure what that means for the future of Kaggle. In any case, um, final thing there then is this point, which is that their claim that successful AI agents, i.e., agents that can solve these Kaggle challenges, could accelerate scientific progress. Now, it's an interesting claim, right? For me, being able to solve completely new to science problems is very different to being able to solve a well-described Kaggle challenge. So I'm not entirely convinced of that leap of logic there, but you know, I can kind of see where they're going with it at least. That if you have an agent that can do machine learning engineering generally, and you've got a way to evaluate how good it is at that, then you could throw at it unsolved big science problems and see what happens. I'll just finish with this 4-point summary of what their contributions are before handing over. They are contributing MLE-bench. We've mentioned that. That is the benchmark of 75 Kaggle competitions. They have a bunch of evaluations off the back of that of current state-of-the-art models and different agent frameworks. They use the term scaffolding kind of interchangeably with framework. It's important to note. And experiments on scaling the resources for these agents, different scenarios, what happens in those scenarios. And finally, they talk about, plagiarism, cheating, effectively whether there's a risk that these agents aren't really solving the problem they're presented with, but they've seen solutions in their training data already, so they're just reproducing those. So, in that case, I believe that's the handover point, if I've not got that wrong, hopefully.
The question now is what data sets, first of all, can I just like call into question the stuff that they had already done? Because I feel like there's a lot here that's kind of like, Matt, you were also mentioning already that like, is this really a way to get to like automating science and to solve kind of like totally open-ended problems? Maybe, but I think they're mostly paying lip service to that because it is a totally different category of a thing. Like from people that have done machine learning in the past, you probably know that what you see on Kaggle is not machine. It is the hard part is how do you even frame the problem in the first place? What should be the machine learning problem, and how do you go from a database to a data set? And by the time they're already done, they give you the data set, they're 99% done. I feel like that's kind of like, okay, sure. So now you're gonna next couple of steps. I'm not really buying it, right? Like I always think that really like the machine learning paradigm comes much earlier into how to even frame the problem in the first place, how to come up with evaluation and validation and what should be the metrics. Like that's the hard work. And I feel like somebody might walk away from this thinking, oh my God, like the AI agents are very good and they can already defeat like humans at Kaggle. Yeah, but that doesn't mean they could do machine learning engineering by my lights. I mean, people could challenge that, but
Yeah. Yeah, it's a massive leap of logic for me, I feel, yeah.
yeah. And I feel like it's the like having written papers before, the fact that they say, oh, this could then be used in order to evaluate, the reasoning capabilities of AI in general and the risk involved. I feel like they just really want that to be true because that makes the paper sound. And I get it, right? Like you got to put in these things, and it's sugar, right? But it makes sense for them to do it. I wish for this to be. This is cool. This would be nice if we can now start evaluating them on actual difficult challenges of machine learning engineering. But okay, with that, and yeah. If
I would
anybody
just
Well, I would just think 'cause it is a huge paper as well, I was thinking about the time we've got to cover it in, because there is more in the introduction because they go into all these details in the introduction that I've skipped, and we could cover that, or we could jump to, like, the experiments, which
yeah.
that's kind of what I was thinking with the yeah.
Yeah, for sure. So the thing that could be, so now that they say, okay, let's take Kaggle data sets, which data set? right? So then it's the whole process of curation, and they're going to go through step by step and say, okay, this is what we're going to remove, this is what we're going to keep, and they have a whole list of like considerations. And I think they have this in the appendix here, the curation criteria. So they manually get rid of this. Filter candidate competitions based on the following criteria. So uh, I think some challenges, some competitions may or may not award a medal. They keep the ones that have medals that could be awarded. Um, competition description is well specified and clear. Again, this is now introducing some more bias into how we should be interpreting the results, right? This is what goes into filtering their data set in the first place. You can evaluate it locally, the evaluation metric. Oftentimes, you just need to send it to the Kaggle API. Competition must have finished before and unlikely to change. Dataset isn't used extensively outside of Kaggle, like MNIST. Everybody knows MNIST. It's probably embedded deep in the weights of whatever model we're going to be using. Train and test sets are from different distributions. The final submission needs to be a CSV file. This is useful because they're expecting the agent to produce that CSV file for analysis and for evaluation. You don't need to require to download the data from outside of Kaggle, and we're allowed to use it. Okay, so this is how they come up with the data set itself. What is the data set? It is a description. So people that know it, there's the overview and data tabs of the competition website. They take that. The data set itself, the grade code used to evaluate the submissions, and a snapshot of the leaderboard. They take all of that and they basically cram it into the context. And they tell the AI to go and solve this. By the way, Matt, am I handing things over to you at some point, or should I keep going?
No, I think if you keep going until section 4.
Till section 4. Okay, great.
Yeah.
So, so they start at 5,000, and then I think they end up with like 75. Okay, 75 competitions. Some of them are low. They rank them based on their complexity. Some are low, as in it just takes a couple hours. Some of them are medium. About 50% are medium. Could take between 2 and 10 hours, they estimate. And some are high complexity. They take even more than. If the data is publicly available, they kind of come up with their own train and test split, not the one from Kaggle, and then they're going to tell the AI to come up with that, to only use their own split. Okay, so really what they're going to do is they're going to try to figure out which scaffold, which agent, and which model is able to win a bunch of medals, and how many medals, and how long does it take them to win those medals. So that's kind of what they're trying to come up with. And how they partition the medals, that depends on the number of teams that had contributed results to each competition. You could see a little bit of here. Okay, if there's less than 100 teams, top 40% win bronze, top 20% win silver, top 10% win gold. They partition it differently depending on the number of teams. There's a way in which you can make a call, I think, to the Kaggle API, and then check whether or not the submission that you're about to submit is valid. And you could get back an answer saying, actually, this is invalid. So what they're doing is they're telling the AI, hey, you should be making sure that all of the submissions that you make are actually valid. That is, we can interpret them, we can rank, we can evaluate them. And this is a little bit of like, there's some code that allows you to run this and to test whether or not what you're about to submit is valid. You'll see that a bunch of them just failed to. It's like, yeah, I know I could do it, but the agents end up not doing it. Like they're not listening. They're not figuring this out. So okay, this is just like the environment. There's some rules, and I think, Matt, you'll probably talk about plagiarism a little bit. We're telling them don't plagiarize, don't break the rules, don't call a friend, don't do a bunch of different things. You'll see whether or not they follow these rules. So okay, now what about the experiments and the results? So here I think we go into some. I did come up with a couple of slides here, so maybe we don't need them. So they come up with different scaffolds, and I wasn't entirely sure what exactly they meant by it. So I did a little bit of digging, and I think this is kind of cool, actually. So the scaffold that ended up working really well is AIDE. I don't know, it might be called AID, right? So the AID scaffold is pretty cool. I think you can go into it. You could see it here. These guys, the WeCo, created this. And it just has a very particular style of generating code through coming up with different nodes. And then you could see which nodes are buggy or not buggy, and then to go and continue to iterate on the basis of that big node map. So here's an example. You could see how the code continues to shift, right? So this is an AI that is generating code in order to, like, it's basically generating like a machine learning pipeline. It's coming up with it and then continuing to iterate and modify its own code. Right? There's like different versions, and then it decided to take on this one, and then to continue doubling down and modifying an existing code. So you could see how they do this for like different data sets, right? This is just a little visual example of how this works. I think they end up calling it a trajectory. So you could see this, but you can also just the aid is open source, so you could just look at it and see exactly how it's doing it, and it's kind of cool, honestly. Maybe I could put this in the chat. If anybody wants to see this, it's actually got a lot out of just like seeing this. So what you could see here, just to give you an example of what a scaffold looks like, agent. Okay, so I think it just has like the run. Generate a natural language plan and the same LLM call and split them apart. Okay, so we're just constantly, you're a Kaggle grandmaster attending a competition. In order to win this competition, you need to come up with an excellent creative plan for a solution and then implement the solution in Python. We will now provide a description of the task. You see kind of like how they're coming up with this, and there's a bunch of different configurations here. Like, oh, if you keep hitting a bunch of bugs, after 20 attempts, you should stop and retrace your step and try a different approach. Like, so all of this is just the complete scaffold for the agent. Debug. Okay, if you notice a bug, perhaps look at try to figure out what the error message is, and on the basis of that, go and modify your code yet again. Right. So this is kind of how it's doing it. Take step by step. So they took this. This is the one that ended up winning, aid, and they made a couple of modifications, and you could sort of see what the modifications are. So these are the parameters that they came up with. This is max debug depth is 20, right? So they've modified it a little bit. I think they added a few other things here too. So forced it to read from JSON, not from JSON-L, all these different things. Okay, so that's the scaffold that they were using. For each scaffold, you can still come up with different models, right? So they tested different scaffolds and different models. And basically they found, okay, O1 preview with aid, it got the most number of submissions in the first place, the highest number of submissions that are actually valid, the highest ones that they, right? It's just defeated everybody else. And they ran it, I think, 3 times on each one just to make sure that they get some variance. Some discussion here. All of them failed to create valid submissions, even though they told them to just check that the submission is valid. They didn't check it. Many of them just stopped halfway, even though they told them, you have full 24 hours. Use up as much time. At some point, the agents are like, I'm done with this. So they just stopped of their own accord, of their own decision. Small details in scaffold implementations made a big difference. So that's kind of interesting. MLE-B, that's the other scaffold, attempted to inspect files that were thousands of lines long, filled up its context window. At some point, they told them, okay, just don't do this. And then it made a big difference. And all of them failed to factor in compute and time limitations to their strategies, which I thought was very, very interesting. Now, the actual results, you could see, I think there's nothing here that I found too surprising. There's like, what happens if you just allow it to attempt to solve the problem more? And what happens if you give it more time? Okay, so number of attempts. Look, as you increase the number of attempts, you just end up succeeding more, basically, right? So, okay, if you give me more attempts to solve the problem, I'll solve it. The other thing is if you give it more time. Let's see. Yeah, you give it more time, the percent of competitions that actually achieve the medal also increases. So yes, more time is better, and more attempts is better. They also made, they also came up with, they changed the hardware a little bit. In this case, they gave it extra GPU. Same as the standard one, 36 vCPUs. This is doing better. Okay, so more time, more attempts, and better hardware gets you better results.
Before I do, what does everyone think of this so far? Any thoughts, any opinions, any like anything to add? I suppose. Do we all think that the experiment, does anyone think there's anything with the experimental methodology that just doesn't quite stack up?
There was something I saw that I found somewhat weird. If you look at the medals, like it seems like they got more gold medals than silver, or and even more so than bronze. Like I would expect, given it's still a low percentage, like that it's kind of a distribution, and that like it should pan off. But it seems for most models, or for all models, that they always have more gold. Like I'm wondering if I'm missing something in the logic there.
Yeah, let's see that.
Page 6.
That reminds me of another thing. Where do you see this?
Page 6 on the top.
Right, 9 point. Well, yeah.
Seems weird, no?
Yeah, how do we make sense of this? It won bronze, it won silver, and it won gold, and it won gold more often than it won silver or bronze. I think it.
Uh, Silver more often than bronze, for that matter.
Yeah.
Yeah.
So it make the distribution be bimodal, because like it's still not half of the cases that it got any medal. So it has some kind of peak way lower, and then it has a peak around gold again.
So it's interesting because I wonder why it lost when it lost, or like why did it fail to get a gold, and why did it get a silver sometimes? What's the difference? What's the distance between silver and gold? Not in terms of like its contribution, but in terms of like not in terms of the score, but in terms of like the method. Is it that it just lacked some hyperparameter optimization, or like could it be that it's just algorithms that are out of the box, which just like doing a good enough job in gold? I don't really. I don't really know. Could be it's always using the same type of model like XGBoost. Yeah, I think a deeper analysis of like when it wins and when it doesn't, and why. Yeah, I think would have been interesting to see.
Okay.
Yeah, and then more broadly, because there's a bunch of dimensions you can analyze this along that they haven't considered probably deliberately. Like, is it good code, for example? Now, maybe being good code isn't the objective. The objective is solving the problem. But I'm gonna off the cuff here a little bit, because a bit later in the paper they talk about the importance of open science. They talk about the importance of reproducibility, and indeed they've made an effort to release everything that they've done and in a way that's reproducible. But and if you had an AI agent and your expectation was that this agent, through doing ML engineering, is going to advance science, and your benchmark is you've come up with this benchmark because you want to know how good that agent is at the task, is a dimension of that good quality code, which it because otherwise the results of the output of the ML agent is not really reproducible or understandable. They haven't really considered that dimension in how they've scored the models, as far as I could see. Correct me if I'm wrong.
I don't even think that they like teased out what the ultimate answer is. You know what I mean? Like in many auto solutions that kind of like that have this like evolutionary conception where you could just see how the pipeline itself continues to evolve. You get a sense. You're like, okay, so this is the winning algorithm, or this is the ensemble of algorithms, and this is our hyperparameters, and this is how we did pre-processing, and this is how we did feature selection. I'm like, I don't think we know any of that here. And for all I know, the difference between gold and silver is just whether or not you added some imputer.
Right. Yeah.
Who knows, right? And for all I know, this is also like if I don't know if somebody is coming in with like a like deeply versed in statistics, I think if like the most rigorous analysis here, I think should be quite skeptical, because who knows how they're using their training data and they could be using it in ways that totally overfit to their training data. And at some point, they came up with some concoction that kind of works on the test, but it's through some witchcraft that you as like as a like trained data scientist would know to avoid.
I think that's a really good point. Yeah. I will just take over the screen share and we can talk about contamination because this maybe also it relates to those questions as well in the sense of it's an additional set of reasons why we might want to be skeptical, but it's something that they acknowledge as well in this case. I found this bit really interesting because it gets to the heart of an emergent challenge, I think, in machine learning, which is models that are trained on data that's originated from models. So contamination, they really need to define what that means first. So they define it as artificially inflated and non-generalizing benchmark performance, which the first time I saw, I thought, well, I'm not entirely sure what you mean by that. What they're talking about is more intuitively this. It's if if the agent develops a solution to this challenge that's actually derived from something that's already known in the public, like every single big Kaggle competition, I would suggest like the top 80% of Kaggle competitions or something ridiculous have been done hundreds of times by all kinds of people all around the world. They've been discussed to death. There are there are blog posts, there are discussion forums, there's all kinds of things on these challenges. Some of these challenges are like standard, introduction to data science, do this Kaggle challenge, or they're part of Kaggle's online learning program. So it's very plausible that the underlying model, the O1 model or whatever model they're using, just to be clear here, the way they've set this up, they have an underlying large language model that is then driving an agent framework. So that underlying model doesn't know it's acting as an agent, if you like, it's just a large language model. It's been prompted to do something that at some point when O1 was trained, it's probably seen every Kaggle competition. And it's seen every discussion forum post about Kaggle competitions. So how do we know that in its solution to this problem, it's not just dredging up stuff that it already knows because it's already seen it? So they try to investigate the effects of contamination. It's interesting they say that because they're kind of assuming contamination is there and they want to see how it's affected everything else. So they try to measure the correlation between how familiar GPT-4o's is with the problem and the performance of the solution. We'd like to know how they know familiarity. We'll come to that in a moment. But they claim there is no evidence of results being systematically inflated due to memorization, which is, to me, a surprising claim. But okay, so we'll run with that. And these diagrams, these came up earlier, but we'll just have a quick scan of these. So this actually relates to the earlier section, but we saw this just now. So where the time we give the model correlates somewhat with its ability to achieve a medal. But this graph here, where they're claiming that there's no real correlation between the familiarity and performance, is kind of interesting. So how do they do this? Well, firstly, they look at blatant plagiarism, where they talk about off-the-shelf detection tools. I think effectively they're looking at, can we say that there's a passage of text or a passage of code that has literally been copy-pasted from something else, in which case we can detect that. Fair enough, but the familiarity is the thing that's a bit harder to quantify. They mentioned that previous work suggests models place a higher probability on tokens in documents they've seen during training. This actually connects to something that I came across and we came across recently in basically trying to figure out whether a model knows something. And there's an idea called perplexity. And I believe this is related to the same idea. Now, someone else probably knows more about this and can correct me if I'm wrong. But the idea of perplexity, it's a concept originally from information theory that measures how surprised we should be by a piece of information. In this case, we might say, well, given if you prompt a model and see its completion and you measure what comes out and the probabilities of what comes out, does the probability distribution of that model's output match what you would expect given what you know about its training data or not? So can you figure out whether a model has seen this thing or not? And in my understanding, that's what they're doing here, or something very similar. Um, but again, I would welcome anyone telling me I'm wrong about that. In any case, they calculate this thing called a mean familiarity, and that's what they use to do the analysis. I'm I mean, I believe that's what they got from their analysis. I don't fully believe that they've thoroughly answered the question here of does the familiar is the model familiar with the source content, and does that familiarity impact performance? I'm not convinced by this. I couldn't tell you what they should have done additionally, but I'm not convinced. Go ahead.
Yeah, I wonder, is there specific mention of perplexity somewhere? Because my first thought was more of a bag of words approximation, where like you could just take a bag of words of the solution and the five most popular discussions and count the frequency of words in those versus the frequency in the actual solution. And I think it's abstract enough in their discussion that we can't really know whether it's the one or the other.
Yeah, and I wonder, do they say anything in the appendices about how that's actually calculated?
But yeah, I imagine that they're just running the model on. Yeah, they give it like the context, and then like yeah, it's just like a growing window of a context. Like they say like, okay, no words. What would be the next word? Next word, and then they're just like taking the probability, and then they're just averaging the probability.
Uh-huh.
Yep.
Right, from like the perplexity kind of style approach, yeah. That yeah, it would make sense. It just like I think there are other ways of doing things that also fit abstract description here, I think.
Quite right. Yes, and that's really the problem here, right? They've not been specific enough about how they've calculated this. They also talk about obfuscation. So the idea is if we change the description of the problem, what happens? Because can we actually like trick the model here? Um, that I found kind of interesting as well because w- wouldn't it? I don't know. Wouldn't it still line up with the original problem in a vector space? I don't know. That's something to consider in this question here. How diverse are Kaggle problems really? There is usually a similar disk structure, right? But there's a lot of similarity. Yeah, exactly, exactly. And that's yeah. So obfuscation is a problem here. I would agree with that. They say that it scores similarly on both the original and obfuscated descriptions, so fair enough. That's good to hear. Um, and no evidence that GPT-4o is overly reliant on the original form. It doesn't rule out subtler contamination, and yeah, that's clearly the case.
Yeah, before we go there, can you see? So I was skeptical of the obfuscation, and I still am somewhat, but I've been won over a little bit by just seeing an example of how they obfuscated. Can you go to maybe page 20, the 25?
Sure.
Oh no, even before 24. So like eight. Yeah, yeah, yeah. So they they did a so you look in the original description. There's a lot going on there.
Let's grab
And
this.
yeah.
Yeah. Predicts interactions between atoms. So imagine something like MRI. Uh-huh. So this is the original description.
Yeah, yeah,
Yeah.
and it's long. It's so long, and like, here's what you need to do, and here's why, and and when you go and you see their obfuscated version, yeah, it's
Just here.
so long, and it's just like a line.
Oh, look at this. Predict the scalar coupling constant. between pairs of molecules, right? But does that scale it? The key thing here is this, right? Does that appear in the original? Yeah, it does, I think. So I wonder if I like you're right. Like you're right in the sense that they've really obfuscated it. But then I think, hey, well, yeah, but scalar coupling constant is in the original description. So if it's seen that, it knows what that is, maybe.
I, I think we could also maybe double click on the word memorization, because there's like the simple kind of like memorizing of, okay, does it know this data set specifically because it has seen this data set? Like that's one type of memorization, maybe fine. Like just a verbatim regurgitation of the, okay, maybe it's not actually doing that. But as somebody said in the chat, all these all these data sets are kind of the same. Like it's all, this is why when you get resumes, for people applying for MLE, they all just have, oh yeah, I've done all these 1,000 Kaggle. Well, of course you've done all these 1,000 because they're all the same.
Yeah,
So
yeah, absolutely.
it's a different. I don't know if it's memorization, but it's like it's it's a type of overfit. I don't know what it is, but it's yeah, maybe memorization. If memorization is a little broader, then you wouldn't know it based on that type of obfuscation gain.
Yeah, no, there's a lot. I feel like there's a lot of depth to all of this that they've not really considered that should. Yeah. Um, I think Adam, you were going to do related work, but should I keep doing the screen share?
Oh no, go for it. Yeah, no, I haven't done related ones. Yeah.
Oh, you've not done it. Okay. Well, I mean, to be fair, we've only got 13 minutes, so maybe I don't need to read through this anyway. Maybe we just leave this for, for those who've read the paper. You might want to read the related work. If you've not read the paper, you might want to read some of the related work. You might prefer it. Who knows? But here it is. So yeah, we don't need to go through all of this, but it kind of maybe shows. Maybe this one is kind of interesting because I'm guessing this is one of the key pieces of background to the what they're doing here with benchmarking. Let's talk about limitations, though. So, contamination and plagiarism, we've already talked about at length, but I think we could probably talk about for another hour. There's so much to it. Um, maybe this suggests that it suggests to me that maybe there's a lot of open questions here. So, novel research needed on how we detect this, how we deal with this, how we even characterize and quantify this kind of contamination, and then coverage of AI R&D capabilities. So we get back to our very bold idea that we're going to be able to jump from doing Kaggle to doing fundamental science. And they say, well, they don't cover the full spectrum of capabilities required for that. In fact, as we've kind of seen that. They're looking at Kaggle problems that provide a clear problem statement, data sets that are clean and well documented, have clear metrics. Real world AI may not even have a clear problem statement. We know that. So, yeah, this is not surprising, but it's good that they acknowledge it. It evaluates many of the core competencies. Sure, I can buy that as well. So we'll give them that. But there's a lot more to be done here. I feel for us to jump to where they want to jump to. Differences to real competitions. Yeah, this I feel doesn't matter so much for our purposes. Yeah, it's going to be, the grading code is they've re-implemented their own grading code for this. Different train test splits. It's just it doesn't actually matter because the thing, their measurement is accurate, that's fine. If that makes sense. At least that's the way I see it. And accessibility, they just talk about how many thousands of hours it takes to run this. It is expensive to do. And there's this last point on AGI, and I kind of want to just run through these two bits quickly because there might be more discussion to be had. AGI preparedness. This is for me was where I thought, yeah, you're really getting ahead of yourselves here now, because if AI agents become capable of autonomously performing ML research, yes, if they do, they'll have numerous positive impacts, accelerating scientific progress in all of these things. Yes, great. But if, right? we're not there yet. And, this we don't have a benchmark here for AI agents being able to do general AI things. We have a benchmark for agents being able to do 75 selected Kaggle competitions in a very controlled circumstances. Um, so yeah, I don't know. I thought, well, I'm not sure. I'm not sure we need this yet. As in this section, not this whole thing. And then the conclusion, interestingly, doesn't actually have very much that we've not seen already. They summarize what's been talked about in the paper. They summarize the work. They summarize some next steps. They hope that it contributes to a deeper understanding and capabilities of agents autonomously executing ML engineering tasks. That's all good. The one thing in the conclusion that I thought was kind of interesting was this reproducibility statement. I like this, and I like the sentiment behind it as an MLOps fan and as a very much a reproducibility fan. The the fact that they seem to care about that and pay attention to that, the extensive appendices reflect that. They have made a good effort here, I think, to make this reproducible. At least, that's the impression I had initially. We have discussed a few aspects here where maybe there are some questions on that now, so maybe it's not as clear as initially. But yeah, that's it for the reading for the content. Any thoughts, questions, discussion?
I do want to throw an idea out here for a minute. And first, maybe one for Benoit and everybody. I don't know. I feel like are we tough judges here? Is like, should we make it so that like if people want to submit papers to archive, first they go through us. We do like first round. You know what I mean? Like we help them.
But it's not been peer reviewed. This is the thing, and I think, I don't know. Maybe we're tough.
This is the peers reviewing it. Okay. The Do you think that there's gonna be like a research? At some point, I thought that there might be like for a long time, I've been thinking there's tension between AI and machine learning, and I wonder whether we're gonna see like a resurgence of machine learning. Because like most people that I know now that are doing AI, they self-proclaim not knowing anything about machine learning because now AI is out of the box with some APIs. Like that's their engagement with it. And I remember that after like ChatGPT came out, a bunch of companies sort of like diverted some money from like traditional ML to just more of like AI stuff. I think that the hard thing about machine learning isn't this, but this is also hard. But could it be that, for example, if somebody's looking for like a next startup idea, just go from a database to the data set, right? And go from a database to a data set and then to a model. That's interesting. And I think that maybe AI and LLMs could be helpful in that. And this is just like one example of how you could kind of go about that. Do you guys think that we might see almost like a resurgence of interest in machine learning now with like that AI might be able to help out with some of the machine learning engineering capability?
I implement AI, and definitely for me, the resurgence in AI is an interest in everything, machine learning, the whole caboose. I've seen a lot of been talking to leadership. Can't really divulge because I work for, you know. But the message I'm hearing is AI or machine learning or intelligent document processing, whatever term you have, is actually the number one priority at this stage. I've seen this huge shift that the intention and resources are devoted in AI from a pure applied AI perspective. Secondly, there's this huge discovery process that's going on. Because part of it is, what the heck are you going to do it? How do you apply it day to day, right? How do you get your ROI? So there's this huge influx on the discovery of how do you do this and get a positive ROI. So in terms of use cases, practical application, just to give you a background, the project I did won a $500,000 award for a big healthcare company. Can't really divulge the details, but we automated faxes of all things using generative AI. And we didn't do RAB, 100% prompt engineering. No RAB, nothing sexy, just hardcore techniques. And the thing is, that won an award, and basically there's this huge clamor to basically make it practical, in that sense. So hopefully that helps.
I'm trying to think. In my experience, it might be partly which bubbles we talk to as well. I think there's a lot of people doing AI who don't have a background in ML because it's very easy to, let's be honest, hook up OpenAI's API to a web front end and get some good results out of it. And that's fine, by the way. There's nothing wrong with doing that. It's a great way to accomplish quite a lot. But I guess maybe the machine learning seems to be. I'm thinking about our customer base. I feel like right now the machine learning is on the fringes of the things that can't easily be solved in language. So we get a lot of interesting vision stuff coming through in particular domains that need actually still to train models or fine tune models at least, and that kind of thing. But yeah, it's an interesting reflection though on where we are.
Yeah, if I have another thought on that, like I think it might depend a little bit what we define as AI and ML, but like one definition I would find useful, and I'm not sure it's very accurate, because AI is the integration of these tools, and the ML is more the evaluation part. And what I expect is that because currently these tools, their APIs are very easy to use, uh, people will integrate them first in many systems without evaluating them, because that's really the hard part. And then you'll have a resurgence of this evaluation, because once you've integrated them a bit everywhere, you start thinking like, well, can we integrate them better? But then you need to quantify how well are they integrated to be able to say whether is this integration better or is this integration better. And then you get back in that science side where like you need to do experiments and evaluate. And I think that fits more to the ML. So I do think there will be a resurgence, but first you have to do all the easy wins of integrating it everywhere where you can just integrate it without knowing whether it's the best way or just a random way.
I think that feels right to me. I think it's likely to. I wouldn't be surprised if a lot of machine learning just emerged that way already, right? From just very low level kind of coding, and then just at some point it just kind of it is very different from like a statistical based approach. It is just much more pragmatically reacting to things.
And I think that phase might be relatively large because evaluation seems to be so hard. Like when we look at these data benchmarks and things like that, there are so many like critical statements we are all making because we're like, well, it's not a very good benchmark because this or that. And I think that's not just like a commentary on how good did the researcher that created the benchmark did their work, but more on how difficult is it to make a good benchmark.
Oh yeah, Mario put in the chat the machine learning versus AI. This is Google Trends. To the rep.
Yeah. Okay. Interesting. Back in my day, AI was machine learning was just part of AI. I've the what's the textbook? Russell and Norvig, big textbook on AI. Is the machine learning was a chapter of that before suddenly everything was deep learning, and now everything's transformers.
Mario, red is AI and blue is machine learning? And do you see so machine learning is still more. Oh wait. But this ends at what year?
This year,
This year? And
2004 to present.
machine learning is it has more interest than AI?
Yeah, man. Just do it.
Mind is blown.
Yeah. I'm just curious because you guys just made me like, what the heck? Let's just figure out what the machine says. The question is, do you trust Google? So I bet you they're like, you pay what $200 for that term in Google Ads.
It's still a more reliable source than the intuition that you have from your own personal experience, I think.
Yeah, it's super interesting because obviously rising tides impact everything. But if you think about it from a demand perspective, machine learning still has the dominant term with people,
Yeah.
right? Because I think it's a because I think the term machine learning, at least for me. So this is the data point of a very biased and flawed person. It's just more relatable. From my experience working with customers, if you talk about AI, man, you're talking about Space Odyssey, craziness, Skynet, and all that shit. Excuse my French. But machine learning, the very term of it is very, very. It's a lot understandable.
Yeah, I wonder how many, how much of this data is made up of by job descriptions. Because you rarely hire for AI, but you hire for ML. But AI is
It's possible. So that there might be survivor's bias, but we will not know. It is driven by purely economics, I'm sure.
Yeah, but if it is their Google searches, I think that like the people in the jobs doing queries for something are gonna dominate the jobs posts, or maybe I underestimate how many job posting goes around. But
Yeah, but I would even argue though that that's the mind frame of the people, right? Assuming there's no bots, right? That's the sentient, that's the prevailing um dominant thing,
hmm.
right? So when you look for a resource or expertise, you're not gonna look for AI. I need an AI expert. I think
y- let's see. Did you put AI? What happens when you put AI and not artificial intelligence?
okay, give me 5 seconds.
Oh my god! All right, I didn't. My model of the world just completely shattered when we artificial intelligence. We're gonna understand it.
But then to make it fair, you should put ML also. Like,
That's fair.
So this reading exercise, I turned into a Google search. So AI still wins by far.
But ML is it's in the running. But look, it's just basically stable for the last few years.
Yeah, but when you think about it, AI, man, like commercially, like people have been talking about it like a bazillion years, right? I would even argue if you look at the 20, I'm curious about that sharp increase on 2012. Maybe some movie came out. It's just interesting. It's just fascinating. So, anyways,
Thank you very much, everybody. And Benoit, thank you for organizing.
Yes, sir. Thanks everybody for joining. Once again, Matt, thank you for covering. For Waldemar as well. Once again, we'll meet next time, everybody. Thanks for joining. Let's got the conversation.